Tonight, we are going to talk about a lie that is taught in every classroom on Earth. It's a word that sounds warm, comforting, and familiar. That word is neighbor. NASA uses it. Textbooks print it. Every astronomer you've ever seen on screen repeats it. They point to a flickering light in the southern sky and tell us that Alpha Centauri is our closest neighbor. But in the cold, brutal reality of physics, a neighbor is someone you can reach, someone you can visit. Someone whose lights you can see and understand in real time. Alpha Centauri is none of those things. Tonight, we are stripping away the clean, academic numbers. We are moving past the abstract term 4 light years because, to a human brain, 4 sounds like a small number. It sounds manageable. It sounds like a weekend trip. But 4 light years isn't a distance. It is a 40 trillion kilometer wall of absolute nothingness. It is a gap so vast that it doesn't just challenge your sense of scale, it shatters it. By the end of this journey, you will understand why our neighbor is actually a ghost, and why the closest star in the sky is perhaps the most terrifying evidence of our isolation in the cosmos. Before we begin our journey into the infinite, if you find peace and wonder in these deep space explorations, please take a moment to subscribe and leave a like. It is a small gesture, but it truly helps this community of curious minds grow. Now, let the world of your daily worries vanish. Let the numbers stop being math and start being feelings. Let the silence of the room around you become the silence of the stars. Let's begin with something you understand perfectly, your own life. You understand distance when it is on a human scale. You know how far it is to the grocery store at the end of your block. A kilometer is a distance most of us can walk in about 12 minutes. It's concrete. But the moment we look at Alpha Centauri, this human instinct fails so spectacularly that it becomes frightening. Imagine you decide to ignore the warnings and start that walk to our nearest neighbor. You step off the Earth and begin walking at a normal human pace. To help you grasp the impossibility, think about this. If you had started that walk when life first appeared in Earth's oceans, 3.5 billion years ago, you would only be arriving tonight. You would have walked through the entire history of life on this planet. You would have seen the first cells divide, the first fish crawl onto land, the rise and fall of every dinosaur, and the birth and death of every human empire, all while taking those same steady steps toward a light that never gets closer. This is the first glitch in our reality. We call it a neighbor, but it is a neighbor that requires 1 billion years of effort to reach. Since walking is impossible, we tree a car. Imagine a highway made of light stretching from your driveway directly to Alpha Centauri. You set your cruise control to 100 kilometers per hour, highway speed, and you never stop. You don't stop for fuel. You don't stop to sleep. To reach that neighboring star, you would be driving for 48 million years. If you had started that car journey when the first primates were beginning to evolve, you would still be behind the wheel tonight. You would have driven through the ice ages and watched the continents drift into their current positions. You would have watched the entire human race evolve from shadows in a cave to masters of the atom, and you still wouldn't be halfway there. This is what astronomers mean when they say space is terrifying. It's not just the size, it's the way it mocks our concept of time. We measure our lives in decades, but the universe operates in millions of years. We built the fastest machine in human history, the Parker Solar Probe, which can travel at 700,000 kilometers per hour. That is fast enough to cross the Atlantic Ocean in 30 seconds. But even at that godlike speed, it would still take over 6,000 years to reach Alpha Centauri. If the ancient people who built the pyramids had launched that probe, it would still be drifting in the dark today, with thousands of years left on its journey. Every king they served, every god they worshipped, and the very language they spoke would be gone, but their machine would still be in the middle of nowhere. Every time we try to bridge this gap with human technology, the math tells us to stay home. Even Voyager One, our most famous interstellar messenger, is currently a snail in a desert. It has been screaming through the void for nearly 50 years, yet it hasn't even covered 0.05% of the distance. It will be 70,000 years before Voyager One even passes near another star. By then, the metal of the ship will be brittle and cold. The plutonium batteries will be dead. The golden record, carrying the laughter of our children and the sound of our rain, will be a silent, golden ghost. Voyager is not a bridge. It is a message in a bottle thrown into a sea that has no shore. This brings us to the most unsettling part of the light year. It isn't just a measure of distance. It is a disconnect from the present. Light is the fastest thing in existence, traveling at 300,000 kilometers every single second. It circles the Earth 7 times in the blink of an eye. But the gap to Alpha Centauri is so wide that even light, the absolute speed limit of reality, takes over 4 years to cross it. When you look at Alpha Centauri tonight, you are seeing a ghost. You are seeing the star as it was 4 years ago. If it had exploded yesterday or vanished from existence this morning, we would have no way of knowing. We would keep seeing its peaceful glow in the sky for years to come. We are looking at a past that no longer exists, trying to touch a destination that is always 4 years ahead of our information. The distance between us and the stars is a wall made of time. And yet there is a reason this wall exists. If the stars were closer, the gravity of those massive suns would tear our solar system apart. The very thing that makes us lonely, the vast, frozen silence of the void, is also the thing that keeps our world stable. The space between the stars is a buffer zone, a protective moat around our small blue sanctuary. As you settle deeper into the quiet of the night, realize that these 40 trillion kilometers aren't just empty space. They are a reminder of how precious our home really is. We live on a tiny island in a dark ocean that is wider than we can imagine. We call Alpha Centauri our neighbor because we are a social species that hates the idea of being alone. But the physics of the void tells us a different story. It tells us that for now, we are the masters of a very small, very beautiful, and very isolated room. Take a final, slow breath now. Let the billions of years and the trillions of kilometers fade into the background. You don't need to cross the void tonight. You only need to appreciate the silence. The scale is infinite, but you are here. The light is old, but it is beautiful. The neighborhood lie is fading. The reality of the 3 suns is beginning. Let us move forward. To understand why Alpha Centauri is a wall, we have to look at the machines we once thought would save us. For decades, we have been building faster and faster engines, believing that engineering could eventually conquer the cosmos. We feel like masters of speed in our modern world. A sniper bullet travels at 3,000 kilometers per hour. A commercial jet feels fast at 900. Even a supersonic fighter jet, screaming across the sky at thousands of kilometers per hour, feels like the absolute limit of human achievement. But here is the first reality check that most people never consider. Against the backdrop of the stars, these machines aren't just slow. They are effectively standing still. Think about the fastest machine humanity has ever put into space, the Parker Solar Probe. This is not a simple rocket. It is a masterpiece of modern physics, a titanium needle designed to touch the very edge of the sun. To reach its top speeds, it doesn't just rely on fuel. It falls toward the sun, using the massive gravity of planets to slingshot itself to a speed of 700,000 kilometers per hour. That is 190 kilometers every single second. At that speed, you could travel from London to New York in less than 30 seconds. You could circle the entire Earth in under 4 minutes. It is a speed that seems almost godlike. It is the pinnacle of everything we have learned about motion since the invention of the wheel. But here is where the loop begins to tighten. If you pointed that godlike machine toward Alpha Centauri tonight, the universe would respond with a cold, terrifying silence. Even at that speed, which is faster than any human has ever traveled, the journey would still take 6,300 years. To help your mind hold that number, we have to look backward. 6,000 years is not just a long time. It is a distance in time that swallows everything we know as civilization. 6,000 years ago, the Great Pyramids of Giza didn't exist. Stonehenge didn't exist. Writing itself was only just beginning to emerge as simple marks on clay tablets in ancient Mesopotamia. Every king who has ever served, every war ever fought, every religion ever founded, and every scientific discovery ever made has happened in a shorter window than that journey. If the ancient people of the Stone Age had possessed the technology to launch this probe, we would still be waiting for it to arrive today. We would have spent the last 60 centuries evolving, building empires, and inventing the internet, while that tiny piece of metal drifted in the total, freezing silence of the void, still thousands of years away from its destination. It would be a relic carrying the hopes of a people we can no longer even understand. This is the second glitch in our reality. We think we are moving, but against the backdrop of 40 trillion kilometers, we are effectively standing still. We are like a grain of dust trying to cross an ocean by falling into the water. We use the word speed because it makes us feel like we have control. But in the interstellar dark, speed is a lie. But perhaps the most heartbreaking part of this math is Voyager One. Launched in 1977, it is our most famous messenger. It has been screaming through the dark for nearly 5 decades. It has left the protective bubble of our sun and entered the interstellar medium. We celebrate it as a triumph, but the math of Voyager One is a reminder of our limitations. In nearly half a century of constant, high-speed travel, Voyager One has covered less than 0.05% of the distance to Alpha Centauri. It will be 70,000 years before it even passes near another star. By then, the metal of the ship will be brittle and cold. The plutonium batteries will be dead. The golden record, carrying the laughter of our children and the sound of our rain, will be a silent, golden ghost. Voyager is not a bridge. It is a message in a bottle thrown into a sea that has no shore. You might ask, why don't we just build a bigger rocket? This is the question that brings us to the ultimate physics prison. To move a spacecraft, you have to throw something out the back. This is the basic law of action and reaction. But to go fast enough to reach Alpha Centauri in a single human lifetime, you would need more fuel than exists in the entire solar system. Chemical rockets are simply too heavy and too weak. They are like trying to power a massive transatlantic ship with a single AA battery. They work tougher moving between planets, but they fail completely when faced with the void. This realization creates a sense of cosmic claustrophobia. We can see our neighbors through our telescopes, but we realize we are effectively chained to our own sun. We are like prisoners looking through a window at a forest that is only a few miles away, but we can never reach the door. This brings us to an even more unsettling possibility. If we were to launch a ship today that could travel at 1% of the speed of light, it would still take over 400 years to arrive. That is 4 centuries of traveling through absolute darkness. The people who arrived at the star would be the great-great-grandchildren of the people who launched. They would have spent their entire lives inside a metal box, never seeing the sky, never feeling a breeze, all to reach a destination they only know through stories. This is the sociology of the void. It's not just a technical challenge, it is a human one. Are we willing to sacrifice generations of people to cross a gap that the universe seems to have designed as a barrier? As you settle deeper into the quiet of the night, let this sense of scale shift from a feeling of despair to a feeling of peace. There is a reason this gap exists. The 40 trillion kilometers between here and Alpha Centauri are not just empty space, they are a sanctuary. They are a protective moat that ensures the violent radiation and chaotic gravity of other star systems stay far away from our fragile atmosphere. The very thing that makes us lonely is the thing that keeps us safe. If the stars were closer, The night sky might be too bright for life to ever evolve. The silence of the void is the price we pay for the stability of our world. Think about the silence that Voyager One is experiencing right now. No wind, no noise, no gravity, just the slow, eternal drift. Voyager is our representative in that silence. It is a tiny piece of us that has escaped the noise of our world and entered the eternal quiet. It reminds us that while we may be trapped, we are also part of something much larger. We are a species that can build a machine and send it into the infinite, even if we know we will never follow it. There is a deep beauty in that act of faith. We realize now that if we ever want to cross this moat, we have to stop thinking about fire and fuel. We have to start thinking about light. We are developing ideas today that involve lasers the size of cities and sails the size of postage stamps, trying to find a way to push a machine to 20% of the speed of light. But even with these miracle technologies, we are still decades away from even the smallest breakthrough. The math remains a wall, and the wall remains undefeated. But as we look past our failing machines, the destination itself begins to emerge from the shadows. And what we see is a system that challenges our very idea of what a home looks like. We are moving toward a world where the rules of our sky no longer apply. We are heading into the heart of the triple sun. Imagine leaving the solitary glow of our sun behind and entering a world where the light never truly leaves the sky. A world of amber afternoons and double shadows. A world where gravity is a three-way tug-of-war that has been playing out for billions of years. We are no longer talking about the journey, we are talking about the arrival. The math of despair is fading, the waltz of the three suns is beginning. Let us move forward. To look at Alpha Centauri is to look at a family that refuses to be alone. In our corner of the galaxy, we are used to a certain kind of solitude. We have our sun, a solitary golden wanderer that sails through the cosmic dark without a companion. For all of human history, this has been our only version of reality. One sun, one sky, one rhythm of day and night. But as we cross the 40 trillion kilometer moat and approach the Centauri system, that reality begins to crumble. We find ourselves entering a complex, beautiful, and violent ballet of three different suns, all locked in a gravitational embrace that has lasted for over 5 billion years. Imagine standing on a world in the middle of this system. In our world, the rhythm of life is defined by a single light. It rises, it sets, and the world goes dark. But in the Centauri system, the very concept of night is something entirely different. It is something alien. To understand this, we have to look at the two largest members of this family. Alpha Centauri A and Alpha Centauri B. They are the giants of the system, and their relationship is a masterpiece of orbital mechanics. Alpha Centauri A is a star that would feel hauntingly familiar to you. It is a G-type main sequence star, which is just a scientific way of saying it is almost an exact twin of our own sun. It is about 10% more massive than our sun and about 50% more luminous. If you could stand on a planet orbiting it, the light hitting your skin would feel the same. The colors of the world around you would be clear and bright. For a human observer, Alpha Centauri A is a piece of home in a foreign sky. But then you notice its companion, Alpha Centauri B. This is not a distant, tiny point of light. It is a second massive sun that dominates the sky. Alpha B is slightly smaller than our sun, a star that glows with a deep, warm amber light. It is cooler than Alpha A, and its light is softer, more orange. Imagine waking up to a double sunrise. First, the brilliant yellow light of Alpha climbs over the horizon, bathing the world in the white gold light you know so well. But shortly after, the amber sun rises. Suddenly, the sky is not just blue, it is a mixture of hues. Your shadow on the ground is no longer a single dark shape. You have two shadows. One is sharp and defined, cast by the yellow sun. The other is softer, slightly blurred, and tinged with orange, cast by the amber sun. These two stars are locked in a gravitational waltz that takes 80 Earth years to complete one single revolution. They don't just sit near each other. They pull on each other with a force that is almost impossible to imagine. They circle a common center of mass, their orbits bringing them close together and then swinging them far apart. At their closest approach, these two suns are about 11 times the distance between the Earth and the Sun. At their farthest, they are about 36 times that distance. To help your mind hold that scale, think about our own solar system. Saturn is about 10 times farther from the Sun than Earth is. Pluto is about 40 times farther. Now imagine if, instead of a frozen planet like Saturn, there was another roaring, massive sun sitting at that distance. Imagine the heat, the light, and the gravity of a second star occupying the same space where our outer planets drift in the dark. This is the reality of Alpha Centauri. It is a crowded house. In our solar system, the space between the planets is mostly empty. It is a quiet, predictable place. But in the Centauri system, the space between the two main suns is a battleground of gravity. Every planet that tries to form there is being pulled in two different directions. It is like a cosmic tug-of-war. For a planet to stay in a stable orbit around Alpha A, it has to stay very close to its parent star. If it wanders too far out, the gravity of the amber sun, Alpha B, will grab it and fling it out of the system or pull it into a collision. This creates what astronomers call the forbidden zone. It is a region of space where no planet can exist for long. We used to believe that this instability meant the Centauri system was a graveyard. We thought that the competing pulls of these two giants would have cleared out any debris billions of years ago, leaving nothing but the two stars dancing alone in the dark. We looked at our own stable, single-sun system and thought this is how it is supposed to be. This is where life belongs, but we were wrong. In the last few decades, we've started to realize that multiple star systems are actually the rule, not the exception. Most stars in the Milky Way are not loners like our Sun. They are part of pairs, triplets, and even larger groups. Our solitary existence might be the glitch, while the chaotic multi-sun ballet of Alpha Centauri might be the standard for the rest of the galaxy. But the mystery of this family goes even deeper, because far away from the brilliant yellow and amber suns, drifting at the very edge of the system's influence, is the third member of the family, Proxima Centauri. If Alpha A and B are the kings of the system, Proxima is the outcast. It is a red dwarf, a star so small and so dim that even though it is technically the closest star to Earth, it is completely invisible to the naked eye. You could look at the exact spot where it sits in the sky with the most powerful binoculars, and you still wouldn't see it. Proxima is nearly a quarter of a light year away from the central pair. That is a distance of about 2 trillion kilometers. It is so far away that it takes over 500,000 years to complete a single orbit around its larger brothers. Think about that time frame. 500,000 years ago, modern humans didn't even exist. Our ancestors were just beginning to master fire. Since the last time Proxima Centauri was in its current position in its orbit, the entire history of the human race has happened. We evolved, we built cities, we fought wars, we landed on the moon, and in all that time, the tiny red star has only moved a fraction of its way around its companions. It is a star that is barely hanging on. It is a red ember drifting and absoluting the absolute blackness, so far from the light of Alpha A and B that it might as well be alone. If you were standing on a planet near the two main suns, Proxima would not look like a sun at all. It would be just a faint, reddish dot, no brighter than any other star in the sky. But Proxima Centauri, despite its small size, is perhaps the most violent star in the system. It is what we call a flare star. Because it is so small, its internal convection is much more turbulent than our sun. It is like a pot of boiling water that never stops. Every few hours, it erupts with massive solar flares. These aren't like the flares we see on our sun. These are explosions so powerful that they can double the star's total brightness in a matter of minutes. They scream out X-rays and ultraviolet radiation that would strip the atmosphere off any planet nearby. It is a tiny, angry star that seems to be struggling against its own nature. As you settle deeper into the quiet of the night, think about the complexity of this family. We used to think our solar system was the standard: one sun, a few planets, and a lot of empty space. But the more we look at the Centauri system, the more we realize that we might be the exception. Most stars in the galaxy have partners. Most worlds have more than one horizon. This realization changes the way we look at our own history. It makes us wonder if we are the lonely ones, tucked away in a quiet corner of the universe, while the rest of the cosmos is a crowded, glowing dance floor. But this beauty comes with a price. The gravity of three suns creates a landscape that is constantly shifting. The three-body problem is a famous concept in physics that describes how three objects moving around each other create a path that is impossible to predict perfectly. It is a system of beautiful chaos, and yet in the middle of this chaos, we have found things that shouldn't be there. We have found evidence that planets can survive the tug-of-war of three suns. We have found that life might be possible in places where the light never truly dies. Take a final, slow breath now. Let the image of the three suns, the yellow, the amber, and the red, settle into your mind. Picture that silent, gravitational dance happening right now, 40 trillion kilometers away. It is happening in total silence. It is happening in total darkness. The stars aren't just points of light. They are massive, roaring engines of fire, locked together by the invisible threads of gravity. The waltz of the three suns is a reminder that the universe is far more crowded, far more active, and far more complex than our lonely little sky suggests. The waltz of the three suns is fading. The reality of a sky with two horizons is beginning. Let us move forward. Imagine standing on a shoreline where the sand is cold, but the sky is on fire. You look up expecting to see the familiar, solitary sun that has governed every day of your life on Earth. But instead, you see something that shatters your understanding of the world. High above the horizon, two massive suns are suspended in a deep sapphire sky. One is a brilliant, blinding white gold, very much like the sun you left behind. The other is a warm, glowing amber, slightly smaller but no less majestic. This is the reality of a world orbiting the Alpha Centauri binary pair. It is a place where the very concept of a day is rewritten, and where the shadows tell a story of two different lives happening at once. In our world, shadows are simple. When you stand in the sunlight, you cast a single dark shape onto the ground. It is a one-to-one relationship. But in the Centauri system, your shadow is a complex, dancing ghost. Because there are two distinct sources of light coming from two different angles, you cast two shadows. One is sharp and dark, created by the intense light of the yellow sun, Alpha Centauri A. The other is softer, slightly larger, and tinged with a deep orange hue, created by the cooler amber light of Alpha Centauri B. As the two suns move across the sky at different speeds, your shadows stretch, overlap, and pull apart. They are a constant reminder that you are living in a world governed by two masters. To understand what this does to a planet, we have to look at the geometry of the sky. Depending on where the planet is in its orbit, the two suns might appear very close together, or they might be on opposite sides of the sky. Imagine a season where as the yellow sun sets in the west, the amber sun is just rising in the east. In this scenario, there is no such thing as night. The world exists in a state of eternal, shifting twilight. You would never see the stars. You would never experience the total ink-black darkness that we know on Earth. Instead, the sky would cycle through shades of deep violet, bruised orange, and soft gold. Life in such a world would have no biological need for the kind of sleep we understand. There would be no circadian rhythm tied to the darkness. Evolution would have to find a way to thrive in a world that is always awake. The colors of this sky would be unlike anything we can find in our own atmosphere. On Earth, our sky is blue because of the way our atmosphere scatters the short wavelength light from our single yellow-white sun. But on a Centauri world, the atmosphere is being hit by two different spectrums of light at once. When the suns are close together, the sky might be a brilliant electric teal. When the orange sun dominates, the atmosphere might turn a deep, dusty crimson. Every sunset would be a masterpiece of conflicting colors. You would watch the yellow sun dip below the horizon, turning the clouds into streaks of gold, only to have the amber sun remain, bathing the landscape in a low, moody light that makes the rocks look like glowing embers. But this beauty hides a fundamental instability. Having two suns doesn't just change the light, it changes the heat. On Earth, our seasons are caused by the tilt of our planet as we orbit the sun. But on a planet in the Centauri system, seasons would be dictated by the distance between the two suns. Alpha Centauri A and B move in an elliptical orbit, meaning they spend decades moving closer to each other and then decades drifting apart. During the years when the suns are at their closest approach, what astronomers call periastron, the total amount of radiation hitting the planet would increase significantly. It would be a great summer that lasts for 20 or 30 years. The oceans would warm, the weather would become more violent, and the atmosphere would churn with the added energy. Then, as the suns begin their long drift apart, the great winter would begin. For the next 40 years, the amber sun would shrink in the sky, becoming a tiny, distant lamp that provides light but very little warmth. The planet would cool, the ice caps would grow, and life would have to huddle in the warmth of the primary yellow sun. It is a world of extreme, long-term cycles. A single human lifetime might only see one or two of these great seasons. It would be a world where history is measured not by years, but by the positions of the two suns. You would tell time by the color of the shadows and the heat of the sky. This creates a psychological environment that is almost impossible for us to imagine. We are creatures of the 24-hour loop. We understand the fast cycle of day and night and the year-long cycle of the seasons, but a Centauri civilization would have to think in terms of decades and centuries. Their concept of time would be stretched. They would look up at the amber sun and know that their grandchildren will see it in a different part of the sky. They would live with the constant, visible proof of the universe's clockwork. There would be no mystery about the motion of the heavens because it would be happening right in front of them, every single day, in two different colors. Most scientists used to think that a planet in this situation would be impossible. They called it the three-body problem. When you have three massive objects, two suns and a planet, their gravitational relationship becomes chaotic. It was believed that the gravity of the second sun would eventually tug the planet out of its stable orbit and fling it into the interstellar dark. We thought the Centauri system was a place where Earths went to die, but our modern simulations have shown us something different. If a planet stays close enough to its primary sun, within a certain safe zone, the gravity of the second sun becomes a gentle, predictable pull rather than a destructive one. It is possible for the world to find a balance. It is possible for a world to exist in the middle of this fire. As you settle deeper into the quiet of the night, try to visualize that balance. You are standing on a planet that is being held by two giant hands of gravity. You feel the warmth of the yellow sun on your face and the orange glow of the amber sun on your back. You see the double shadows stretching out before you, merging and splitting as the hours pass. You realize that you are part of a system that is far more vibrant and far more alive than our lonely little solar system. Our sun is a solitary light in a dark room, but Alpha Centauri is a cathedral of light, where the pillars are made of fire and the roof is a sapphire sky. But even this magnificent dance is not the whole story. Because as you look past the two brilliant suns, past the golden afternoons and the teal skies, you remember that there is a third member of this family, a hidden ghost that is watching from a distance. a star that is so small it doesn't even contribute to the light of your day, but so important that it holds the key to our understanding of the void. We have seen the kings of the system, but now we must face the outcast. We must move beyond the amber glow and head toward the tiny, angry ember that sits at the edge of the family. Take a final, slow breath now. Let the image of the double shadows and the sapphire sky settle into your mind. Picture the two suns, the yellow and the amber, slowly circling each other in the silent dark. They are a reminder that the universe loves complexity. They are a reminder that even in the most chaotic environments, a fragile world can find a way to exist. But the peace of the double suns is about to change. We are leaving the warmth of the central pair and heading into the cold, red light of the distance. The sky of two suns is fading. The mystery of the red ghost is beginning. Let us move forward. As we drift away from the brilliant, sapphire sky of the twin suns, we begin to enter a region of the system that feels fundamentally different. The warmth of the yellow and amber stars starts to fade, and the light behind us begins to shrink until the two massive suns are just two exceptionally bright dots in a sea of black. We are heading toward the edge of the family's reach, crossing nearly 2 trillion kilometers of absolute silence. This is the realm of the third brother, the outcast, the red ghost. This is Proxima Centauri. To understand Proxima, you first have to understand why it is called a ghost. If you were to walk outside tonight and look toward the constellation of Centaurus, even with a high-end backyard telescope, you would never see this star. It is technically the closest star to the Earth. It is our nearest cosmic neighbor in the truest sense of the word. And yet, it is so small and so dim that it is entirely invisible to the naked eye. It is a star that hides in plain sight. It is a red dwarf, a category of star that is the most common in the universe, yet the most difficult to find. Proxima is roughly 1/8 the mass of our Sun. If our Sun were the size of a basketball, Proxima would be the size of a small grapefruit. It is so small that it is barely a star at all. If it were just a little bit smaller, it wouldn't have enough gravity to ignite the nuclear fire in its core, and it would have drifted through the galaxy as a cold brown dwarf, a failed sun. But it just barely made the cut. It is a tiny, smoldering ember in a fireplace that is billions of light years wide. Because it is so small, it burns its fuel at an incredibly slow pace. Our sun is in its middle age and will likely die in another 5 billion years, but Proxima Centauri is built to last. It is so efficient with its hydrogen that it will keep glowing for trillions of years. It was here long before our sun was born, and it will still be shining long after our sun has turned into a cold diamond and the Earth has been swallowed by fire. In a universe that often feels violent and short-lived, Proxima is a monument to cosmic patience. It is the ultimate survivor. But do not let its small size or its dim light fool you into thinking it is peaceful. Proxima Centauri is what astronomers call a flare star, and it is perhaps one of the most violent objects in our neighborhood. Because the star is so small, its internal gases are constantly churning in a process called convection. Think of a pot of thick soup boiling on a stove. The bubbles don't just sit on the surface, they rise from the very bottom, exploding upward with incredible force. In Proxima, this constant churning creates massive magnetic fields that get twisted and tangled like rubber bands being stretched to their breaking point. When these magnetic lines finally snap, they release a burst of energy that is almost incomprehensible. These are solar flares, but they are far more terrifying than anything our sun produces. In a matter of seconds, Proxima can double its total brightness. It screams out a blast of X-rays and ultraviolet radiation so powerful that it would strip the atmosphere off a planet in a heartbeat. It is a tiny star with a giant temper, a red ghost that occasionally turns into a roaring monster. As you settle deeper into the quiet of the night, let the distance of Proxima sink into your mind. It is nearly 13,000 times farther from its two larger brothers than the Earth is from the Sun. It is so far away that for a long time, astronomers weren't even sure if it was actually part of the Alpha Centauri family. They thought it might just be a random star passing through the neighborhood, but we now know it is locked in a slow, agonizingly long orbit. It takes Proxima over 500,000 years to complete one single trip around the central binary pair. Think about that timescale in terms of human history. 500,000 years ago, the first modern humans hadn't even appeared on Earth. Our ancestors were living in the Stone Age, struggling to survive against the elements. Since the last time Proxima was in its current position in its orbit, the entire story of humanity has played out. We learned to use fire, we built the first cities, we invented writing, we discovered electricity, and we landed on the moon. And in all that time, all those centuries of human struggle and triumph, Proxima Centauri has only completed one single lap around its brothers. In the interstellar dark, time doesn't work the way we think it does. We measure our lives in days and years, but Proxima measures its life in eons. It is a star that watches the galaxy rotate with the patience of a mountain. It is a silent witness to the passage of time on a scale we can barely imagine. If you were standing on a planet orbiting Proxima, the sky would be a place of haunting beauty and constant fear. During the quiet moments, your world would be bathed in a deep, moody crimson light. The sun in your sky would not be a brilliant yellow disk. It would be a large, dark red orb that provides a cold, dim light. The landscape around you would look like it was permanently trapped in the final minutes of a sunset. The plants, if they could survive, might be black or dark purple, designed to soak up every tiny bit of red light the star provides. But then, without warning, the flare would hit. The sky would suddenly turn a brilliant, blinding white. The radiation would wash over the world, and if you weren't protected by miles of rock or a massive ocean, you would be erased in an instant. This is the paradox of Proxima. It is the closest star, the most reachable destination, and yet it is one of the most hostile environments in the known universe. It is a red ghost that guards its secrets with fire. Most people look at the stars and see hope. They see a future where we leave our small world and find a new home. We point to Proxima because it is the closest, the most logical first step. But the reality of the red ghost is a reminder that the universe doesn't care about our plans. It doesn't build neighborhoods that are easy for us to live in. It builds systems that operate on laws of physics that are brutal and uncaring. Proxima is a lesson in humility. It tells us that even if we can cross the 40 trillion kilometers of empty space, we might find ourselves face to face with a star that is actively trying to destroy us. And yet, despite the flares, despite the radiation, and despite the absolute isolation of this red ghost, we have found something orbiting it. We have found a reason to keep looking. In the middle of all that fire and all that darkness, there is a small, rocky world that refuses to be ignored. It is a world that sits in the most dangerous part of the system, yet it holds the key to the biggest question we have ever asked. Are we alone? Take a final, slow breath now. Let the image of the red ghost, the tiny smoldering ember in the dark, settle into your mind. Picture it drifting, silent and angry, at the edge of the Centauri family. It is a star that has been there for billions of years, and it will be there for trillions more. It is a reminder that we are just temporary visitors in a much older, much grander story. The mystery of the red ghost is fading. The forbidden home is beginning. Let us move forward. In August of 2016, a group of astronomers made an announcement that sent a ripple of excitement and terror across the scientific world. They had found it. Orbiting the red ghost, Proxima Centauri was a planet. It wasn't a gas giant like Jupiter or a frozen rock like Pluto. It was a rocky world, just slightly larger than our Earth, sitting in the very heart of the star's habitable zone. For a few brief days, the headlines across the globe were filled with hope. We had found a second Earth. We had found a place where liquid water could exist. We had found a potential home. But as the data continued to pour in, we realized that Proxima b is not a second Earth. It is a beautiful, forbidden nightmare. To understand why this world is so strange, you first have to visualize its relationship with its star. Proxima b is not 93 million miles away from its sun like we are. It is so close that it completes an entire orbit, a full year, in just 11 Earth days. Imagine having a birthday every week and a half. Because it is so close, the gravitational pull of Proxima Centauri has locked the planet in place. This is a process called tidal locking. It is the same thing that happened to our moon. It means that Proxima b does not rotate the way Earth does. One side of the planet is permanently turned toward the star, locked in an eternal scorching day. The other side is permanently turned toward the void, locked in a deep, freezing, and eternal night. Imagine waking up on the day side of this world. There is no morning, there is no noon, there is no evening. The red sun is simply there. It hangs in the exact same spot in the sky, never moving, never setting. It is a giant dark crimson eye that watches you forever. On this side of the planet, the heat is unrelenting. The ground is baked. The water, if it exists, would be a thick, steaming soup or perhaps entirely evaporated. It is a world of permanent red light, where shadows never move and time feels like it has come to a complete standstill. But then you look toward the other side. If you were to travel across the planet, you would eventually reach the dark side. Here, the red sun disappears entirely. The sky becomes a deep, terrifying black, filled with stars that never fade and never change position. Without the warmth of a star, the temperature on this side drops to hundreds of degrees below zero. The air itself might be frozen, lying on the ground like a blanket of nitrogen snow. It is a landscape of absolute silence and absolute ice. It is a place where no life as we know it could ever survive. But between these two extremes, the fire and the ice, there is a thin, mysterious sliver of land. Astronomers call it the Terminator line. This is the region where the eternal day meets the eternal night. It is a place of permanent twilight. If you stood here, the red sun would be forever half sunken on the horizon. The sky would be a constant, bruised shade of orange and purple. This is the only place on the planet where the temperature might be just right. This is the forbidden home. Imagine the weather in this twilight zone. Because one half of the planet is boiling and the other is freezing, the atmosphere is in a state of constant, violent movement. Cold air from the night side screams toward the heat of the day side, creating windstorms that would make the most powerful hurricane on Earth look like a gentle breeze. The clouds would be a chaotic swirl of purple and gray, lit from below by the permanent sunset. It would be a world of constant noise, the sound of the wind never stopping, a low, eternal roar that has lasted for billions of years. But the winds are not the biggest threat to this world. As we learned, Proxima Centauri is a flare star. Every few hours, it erupts with a blast of radiation that would be catastrophic for our Earth. On Proxima b, these flares hit with a force that is almost impossible to comprehend. Imagine the red sun suddenly turning white and doubling in size. A wave of X-rays and ultraviolet light washes over the planet, hitting the atmosphere like a physical hammer. If Proxima b didn't have a massive magnetic field, its atmosphere would have been stripped away eons ago, leaving it a dead, airless rock like our moon. This brings us to the biggest question of all. Could anything live in such a place? Could life find a way to thrive in a world of permanent red twilight, caught between a frozen void and a radiation-spewing sun? At first, it seems impossible, but life has a strange way of surprising us. On Earth, we have found organisms that live inside nuclear reactors at the bottom of the deepest oceans and inside solid rock. We call them extremophiles. If life exists on Proxima b, it would be alien beyond our wildest dreams. Perhaps it lives entirely underground, safe from the radiation of the flares. Perhaps it lives deep in the oceans, where miles of water act as a shield against the star's temper. Or perhaps it has evolved a way to use that radiation as energy. Imagine plants that are not green, but black, designed to soak up every tiny bit of light from a dark red sun. Imagine creatures that have no concept of a day or a year, whose entire existence is defined by the rhythm of the flares. The reality of Proxima b is a lesson in perspective. We spend our lives looking for another Earth, a planet B where we can move if things go wrong here. But when we look at our nearest neighbor, we find a world that is so hostile, so strange, and so forbidden that it makes us realize how lucky we truly are. Earth is a rare sanctuary. It is a place where the sun is stable, the nights are cool, and the seasons are gentle. Proxima b is a reminder that in the cosmos, habitable doesn't mean comfortable, it just means possible. Think about the silence of this world. Right now, 40 trillion kilometers away, that red sun is hanging on that horizon. Those winds are screaming across that twilight zone. That planet is orbiting its star in total, lonely silence, just as it has for billions of years. It is a world that has never seen a human, never heard a voice, and never felt a gentle rain. It is a ghost of a world, a place that might be full of life, or might be as empty as the void itself. We point our most powerful telescopes at this world, trying to see if there is oxygen in its air or liquid water in its oceans. We are trying to bridge the gap of 40 trillion kilometers with nothing but light. We are desperate to know if we have a neighbor, even if that neighbor is a beautiful nightmare. Because as scary as Proxima b is, the alternative is even scarier. The alternative is that the universe is empty. But as we look at this forbidden home, we eventually have to look past the planet itself. We have to look at the space that separates us from it. Because even if we could build a ship to reach Proxima b, we would have to cross the most terrifying region of the cosmos. We would have to leave the warmth of the suns behind and enter the true intergalactic night. We would have to face the absolute zero of the void. Take a final, slow breath now. Let the image of the fire and ice on Proxima b settle into your mind. Picture that permanent red sunset hanging over a frozen horizon. It is a world that is waiting for us, guarded by the red ghost and hidden by the dark. But the journey to reach it is far more dangerous than the planet itself. The mystery of the forbidden home is fading. The ocean of nothingness is beginning. Let us move forward. As we leave the violent flares and the red twilight of Proxima Centauri behind, we enter the most honest part of the universe. We often think of space as a collection of things: stars, planets, nebulae, and galaxies. We focus on the lights because they are what we can see, but the reality of the cosmos is that it is not made of things. It is made of nothing. The space between the stars, the vast, echoing gap that separates us from Alpha Centauri, is a vacuum so absolute and so deep that it challenges the very definition of existence. This is the interstellar medium, the great ocean of nothingness that every traveler must cross. It is a place where the human mind, built to understand air and sound and warmth, finally meets its limit. Imagine stepping out of your ship in the exact midpoint between our sun and Alpha Centauri. You are 2 light years from home in one direction and 2 light years from your destination in the other. In every direction you look, there is only the infinite black. Here, the sun is no longer the roaring engine of life that you know. It has shrunk to a bright, cold point of light, no more special than any other star in the sky. You have lost your home star. You have lost your sense of up and down. You are floating in a place where there is no horizon, no ground, and no sky. You are a single atom of life in a desert of non-existence that stretches for trillions of kilometers. This is where the true terror of the void begins. On Earth, even in the middle of the night, we are surrounded by things. We feel the air against our skin. We hear the distant hum of the world. We feel the pull of gravity beneath our feet. But in the interstellar void, all of these sensations are stripped away. There is no air to carry a sound. If you were to scream with all your might, the silence would remain unbroken. The sound waves would have no medium to travel through. They would simply die in your throat. It is a silence so total that it feels like a physical weight pressing against your ears. It is the silence of a universe that isn't listening. Then there is the cold. We use the word cold on Earth to describe a winter morning or the ice in a drink. But the cold of the interstellar void is something else entirely. It is what scientists call absolute zero. It is roughly minus 273 degrees Celsius. At this temperature, the very laws of physics begin to change. Heat is just the vibration of atoms. On Earth, atoms are always dancing, moving, and bumping into each other. But in the deep void, the heat has been sucked away so completely that the atoms almost stop moving. It is a cold so intense that it doesn't just freeze your skin, it freezes the very concept of motion. It is a place where time itself feels like it has been preserved in ice. As you settle deeper into the quiet of the night, let the scale of this nothingness sink in. We often imagine space as being empty, but we don't realize how empty it truly is. If you were to take a volume of space the size of a large football stadium in the interstellar void, you might find only a few dozen atoms of hydrogen drifting inside it. On Earth, that same stadium would contain trillions of molecules of air. Space is so empty that light can travel for thousands of years without ever hitting a single obstacle. It is a vacuum so perfect that it makes anything we can create in a lab look crowded. But even in this absolute nothingness, there are hidden dangers. Because there is no atmosphere to protect you, the void is filled with cosmic rays, high-energy particles that move at nearly the speed of light. They are the shrapnel of distant supernova explosions, traveling across the galaxy for millions of years. In the void, these invisible bullets are constantly screaming through space. If you were standing there, they would pass through your body like ghosts, shredding your DNA and breaking the very blueprints of your life. The void is not just empty, it is a radioactive shooting gallery where the bullets never stop. And yet there is a strange, haunting beauty in this isolation. Because there is no air to scatter light, the stars do not twinkle. They are sharp, steady, and brilliant. You see colors you can never see from Earth, subtle shades of violet, deep blues, and piercing whites. You see the Milky Way not as a faint smudge, but as a massive, glowing river of silver dust that spans the entire horizon. In the absolute darkness of the void, your eyes finally see the universe as it really is. It is a cathedral made of light and shadow, where the silence is the only prayer. Think about the objects that live in this nothingness. We call them rogue planets. These are worlds that were kicked out of their solar systems billions of years ago. They drift through the interstellar void in total darkness, with no sun to warm them and no morning to wake them. There are likely billions of these ghost worlds in the gap between the stars. As you drift through the nothingness toward Alpha Centauri, you might pass one of these worlds. It would be a dark, silent sphere, invisible to the eye, a frozen tomb traveling through the dark at thousands of kilometers per hour. These are the orphans of the cosmos, the ultimate proof of how cold and uncaring the void can be. This is the reality of the moat that surrounds our Earth. We live on a tiny, warm island protected by a thin blanket of air, while just beyond our reach is an ocean of absolute zero and absolute silence. We are like children sitting by a campfire in the middle of a vast, dark forest. The fire gives us light and warmth, but we know that if we step away from its glow, the darkness will swallow us. The interstellar void is that darkness. It is the vast, echoing room in which our entire history is just a tiny, flickering candle. But the most mysterious thing about this nothingness is that it isn't actually empty. Modern physics tells us that even empty space is filled with energy. There are fields of force that we cannot see, and particles that pop in and out of existence in a fraction of a second. The void is actually a churning sea of potential, the very fabric from which the universe was woven. When you look at the gap between us and Alpha Centauri, you aren't looking at a hole in the universe. You are looking at the universe itself. You are looking at the stage upon which the stars are built. As you get sleepier and the silence of the night surrounds you, try to visualize yourself floating in that midpoint again. You look back at the tiny, distant sun. You look forward at the tiny, distant Alpha Centauri. You are held in the grip of a piece that is older than the planets. There is no hurry here. There are no deadlines. There is no noise. There is only the slow, steady rhythm of your own breath, echoing in the vast, silent cathedral of the void. You are a part of the nothingness, and for a moment, the nothingness is a part of you. This is the price of the journey. To reach our neighbor, we must be willing to face the absolute silence. We must be willing to spend years in a place where time feels like it has stopped. We must be willing to be alone in a way that no human has ever been alone before. The interstellar void is the ultimate test of our species. It is a reminder that the universe is not made for us. It is a place where we are just temporary visitors, trying to find a way to cross an ocean that has no end. But as we look at this nothingness, we eventually have to ask, why can't we just go faster? If the void is so empty and so vast, why is there a limit to how quickly we can cross it? Why is there a speed that we can never, ever break? In our library of the impossible, we have found that the universe has a speed limit, and that limit is the most absolute wall of all. It is a rule that was written into the fabric of space and time at the moment of the Big Bang, and it is a rule that dictates our fate among the stars. Take a final, slow breath now. Let the cold and the silence of the interstellar void settle into your mind. Picture yourself drifting, a silent point of light in a sea of infinite black. You are safe here in your room, but your mind is out there in the great nothingness. The scale is infinite, but the peace is total. The ocean of nothingness is fading. The speed limit of reality is beginning. Let us move forward. We are a species that hates being told no. Throughout our entire history, we have treated every limit as a challenge and every wall as something to be broken. When we were told we couldn't fly, we built wings. When we were told we couldn't leave our planet, we built rockets that could pierce the atmosphere. We have spent thousands of years accelerating, moving faster and faster from the pace of a walking man to the screaming speed of a jet. In our minds, speed is simply a matter of power. If you want to go faster, you just need a bigger engine, more fuel, and more force. But as we look out across the 40 trillion kilometers toward Alpha Centauri, we run into a rule that doesn't care about our determination. We encounter a law that cannot be negotiated, bribed, or out-engineered. We meet the absolute speed limit of the universe. Tonight, we explore the most frustrating and profound boundary in all of physics, the speed of light. It is roughly 300,000 kilometers per second. To our human minds, this number sounds like an invitation. It sounds like a goal we might one day reach if we just work hard enough, but the reality is far more unsettling. The speed of light is not just a speed that light happens to travel at. It is the speed of causality itself. It is the maximum speed at which information can move through the fabric of space and time. It is a fundamental property of the universe, like gravity or the passing of time. It is the universal no. To understand why this is a wall, imagine you are in a spacecraft that has the most powerful engine ever conceived. You are heading toward Alpha Centauri, and you are pushing your ship harder and harder. As you add energy, you go faster. You reach 10% of the speed of light, then 20, then 50. On Earth, if you add more energy to a car, it simply goes faster. But in the deep physics of the cosmos, something strange begins to happen as you approach the speed of light. According to Einstein's theory of relativity, as an object moves faster, its mass effectively increases. It's not that you're adding more physical matter to the ship. It's that the ship becomes heavier in the eyes of physics. It becomes harder to push. Think about what this means for your journey. The closer you get to that 300,000 kilometer per second mark, the more energy you need to gain just 1 more kilometer of speed. If you reach 90% of the speed of light, your ship feels massive. If you reach 99%, the energy required to go even a tiny bit faster becomes staggering. To actually reach the speed of light, you would need an infinite amount of energy. Not just a lot of energy, not the energy of a sun or a galaxy, but infinite energy. And because the universe does not contain infinite energy, the speed of light is a barrier that no object with mass can ever cross. It is a physical law that dictates we can never catch up to a photon. This realization is the ultimate glitch in our dreams of interstellar travel. Even if we had a ship that could run on the power of 1,000 stars, we would still be trapped behind this line. We are like a runner on a treadmill that gets faster and steeper the harder we run. No matter how much effort we put in, the end of the treadmill remains out of reach. This is why Alpha Centauri is so terrifyingly far away. It's not just the distance in kilometers. It's the fact that even if we could move as fast as the universe allows, the trip would still take years. We are limited by the very structure of reality. As you settle deeper into the quiet of the night, let the weight of this limit rest over you. It changes the way we see the stars. When you look at Alpha Centauri, you're seeing light that has traveled for 4 years and 3 months. That light is moving at the absolute maximum speed allowed. It is the fastest news we can ever receive from our neighbor. If an alien civilization at Alpha Centauri tried to send us a message today, we wouldn't receive it until years into our future. There is no such thing as a live conversation between stars. The speed of light ensures that every star system is an island, disconnected from the present moment of every other star. We are all living in each other's past. But why does this limit exist? Why is the universe built with a speed cap? Some scientists believe it is because space and time are not just an empty stage, they are a fabric. And like any material, this fabric has properties. Just as sound has a maximum speed it can travel through air, information has a maximum speed it can travel through space-time. If information could travel instantly, the very concept of cause and effect would break down. You could see an effect before you saw the cause. You could, in theory, travel backward in time and change the past. The speed of light is the universe's way of keeping its story in order. It is the glue that keeps the timeline from unraveling. Think about the photons themselves. A photon is a particle of light and it has no mass. Because it has no mass, it is not weighed down by the same rules that trap our ships. A photon travels at the speed of light from the moment it is born to the moment it is destroyed. But here is the most mind-bending part of the speed limit. From the perspective of a photon, time does not exist. If you could ride a beam of light from Alpha Centauri to Earth, you wouldn't experience those 4 years of travel. To you, the journey would be instantaneous. You would leave the star and arrive at the eye of a human on Earth in the same moment. At the speed of light, distance and time collapse into nothing. This is the strange paradox of our isolation. To the light itself, the universe is a small, connected place. To us, made of heavy atoms and bound by the laws of mass, the universe is vast and fragmented. We are the slow parts of the cosmos, looking out at a fast world that we can never truly join. We are like spectators at a race, watching the light scream past us at a speed we can only dream of. The speed limit of reality is the reason we feel small. It is the reason the gap to Alpha Centauri feels like a prison. It reminds us that we are not the masters of the universe, we are its subjects. As you get sleepier and the silence of the night surrounds you, try to visualize that speed limit as a soft, glowing curtain that hangs between us and the stars. It is beautiful, but it is absolute. You see the light from Alpha Centauri hitting that curtain and then drifting toward us, taking its time, refusing to be rushed. You realize that the universe has a rhythm that is far slower and more patient than our human lives. We want everything now. We want to be there now. But the stars tell us to wait. They tell us that time is the price we pay for existence. But even with this absolute limit, we haven't given up. If we can't break the speed of light, we are looking for ways to get as close to it as possible. We are looking for glitches in the rules. What if we didn't have to move through space? What if we could move space itself? This is the realm of theoretical physics, where we talk about bending the fabric of the cosmos to create shortcuts. We talk about warp drives and wormholes, ideas that sound like magic, but are actually buried in the complicated math of Einstein's own equations. We are looking for a way to cheat the limit without breaking the law. For now, the law remains, and the law says that Alpha Centauri is 4 years away at the very least. This means that any journey we take will be a journey into the deep future. If you were to leave for Alpha Centauri today in a ship traveling near the speed of light, you would return to an Earth that has aged decades or even centuries, while you have only aged a few years. This is called time dilation, and it is the most haunting consequence of the speed limit. To cross the void is to leave your life behind. It is a one-way trip into a future you were never meant to see. Take a final, slow breath now. Let the absolute limit of the speed of light settle into your mind. You don't need to go fast tonight. You only need to be still. The stars are far away, and they are moving according to a clock that is much grander than ours. The speed of light is not a wall to be angry at. It is a boundary to be respected. It is the silence that allows the stars to be stars and the void to be the void. The scale is infinite, the limit is absolute, but the peace is total. You are safe in the slow world, protected by the very laws that keep the stars out of reach. The speed limit of reality is fading. The tragedy of time dilation is beginning. Let us move forward. Imagine you have finally done it. You are standing on the deck of a ship that has achieved the impossible. Through decades of scientific struggle and trillions of dollars in investment, humanity has built a vessel capable of traveling at 99% of the speed of light. You are the pilot of this needle of light, and your destination is Alpha Centauri. As the engines roar into life and the sun begins to shrink behind you, you feel a sense of triumph. You are the first human to truly bridge the gap. You are moving so fast that the stars in front of you begin to change color, shifting into a brilliant electric blue. You look at the clock on your dashboard, and it is ticking normally. You feel your heart beating in your chest, and it feels exactly as it did on Earth. To you inside this ship, life is continuing just as it always has. But outside these titanium walls, the universe is performing a cruel trick on your reality. This is the tragedy of time dilation, the most haunting consequence of Einstein's laws of physics. As you settle into the quiet of your room tonight, try to grasp this. Time is not a universal constant. It is not a river that flows at the same speed for everyone. Time is flexible. It can be stretched, compressed, and distorted by speed. And as you scream toward Alpha Centauri at nearly the speed of light, you are not just traveling through space. You are traveling through time. You are leaving the present moment of the human race behind forever. To understand this, we have to look at the twin paradox. Imagine you have a twin brother who stays on Earth while you leave for your mission. You are both 25 years old. You accelerate to 99% of the speed of light, travel to Alpha Centauri, spend a few days exploring the triple sun system, and then turn around and head home at the same incredible speed. From your perspective, the journey is fast. Because you are moving so close to the speed limit of the universe, time for you has slowed down significantly. You look in the mirror after your return, and you have aged maybe 2 or 3 years. Your skin is still young. Your mind is still sharp. You feel like you've only been gone for a long vacation. But as your ship touches down on Earth, you realize that the world you left is gone. You step out of the hangar and you don't see your twin brother waiting for you. Instead, you see a man in his 90s, or perhaps you see a grave. While you were gone for 3 years, nearly 70 years have passed on Earth. The friends you had are gone. The parents you loved are memories. The very culture, the language, and the technology of your home have moved on without you. You have returned to a future that has no place for you. You are a ghost from the past, a young man in a world of old men. This is the price of crossing the void. To touch the stars is to lose your home. This isn't science fiction. It is a measured, proven fact of our universe. We see it every day in our particle accelerators, where tiny subatomic particles are pushed to near-light speeds. To us, these particles should decay and vanish in a fraction of a second, but because they are moving so fast, their internal clocks slow down. They live tens or even hundreds of times longer than they should. We see it in our GPS satellites, which move fast enough that their clocks get slightly out of sync with the clocks on the ground. Every day, engineers have to manually correct for time dilation just to make sure your phone can tell you where you are on a map. The universe is telling us, in small and large ways, that time is the currency we must pay if we want to move through the dark. Think about the psychological weight of this reality. If we ever send humans to Alpha Centauri, they will be the most isolated people in history. It isn't just the 40 trillion kilometers of distance. It's the realization that they can never truly go back. Every second they spend accelerating is a year being stolen from their loved ones back home. If they send a video message back to Earth saying, "We've arrived," the people who receive that message will be the grandchildren of the people they said goodbye to. Interstellar travel is a form of one-way time travel. It is a slow, steady goodbye to everything you have ever known. As you get sleepier and the silence of the night surrounds you, try to visualize that ship again. You are drifting through the absolute zero of the void, and you look at your watch. The second hand moves. Tick, tick. Tick. Each of those ticks is a normal second for you. You can read a book, you can eat a meal, you can have a conversation. But every time that hand moves, weeks are passing on Earth. Seasons are changing. Children are being born and growing old. Entire forests are growing and being cut down. You are suspended in a bubble of slow time, while the rest of humanity is screaming forward into the future. It is a loneliness that no poet has ever been able to fully describe. This is the hidden reason why we haven't seen any galactic empires. Even if a civilization develops the technology to travel between the stars, the time barrier makes it almost impossible to maintain a society. How can you have a government when it takes 100 years to receive an answer to a question? How can you have a family when your children age decades while you are on a business trip to the next star? The universe seems to have built-in protections against us spreading too far. It uses the speed of light and the distortion of time as a natural cage. It keeps us local. It keeps us small. Most people carry the idea that future technology will solve these problems. We think we'll find a way to skip the time or cheat the physics. But time dilation isn't a technical bug. It is a feature of space-time itself. It is the very fabric of how things move. To go to Alpha Centauri is to accept that you are becoming a part of the stars, and the stars do not live on human time. They live on cosmic time. They see the rise and fall of planets as if they were bubbles in a stream. To join them, you must give up your connection to the fast-moving, flickering world of human life. Imagine the silence on that ship as you approach the amber and yellow suns of Alpha Centauri. You have done it. You are there. You see the double shadows on the floor of your cabin. You see the massive engines of fire through the viewing port. It is the greatest achievement in the history of your species. But in the back of your mind, there is a quiet, aching sorrow. You know that back on the small blue dot you call home, no one remembers your name. You are a hero to a world that has forgotten you existed. You are an explorer of the infinite, but you are a stranger to your own kind. This is the ultimate irony of the search for a new home. We look to Alpha Centauri because we want to ensure the survival of humanity. We want to find a planet B where we can carry on our legacy. But the physics of the journey ensures that the people who arrive will be fundamentally different from the people who stayed. They will be people of the void. They will be creatures of the long, slow drift. By the time we reach the stars, we will no longer be the same humans who looked up from the caves of Earth. We will have been transformed by the very time we tried to conquer. Take a final, slow breath now. Let the tragedy of time dilation settle into your mind. You are safe in the now. You are connected to the present moment of everyone on this planet. Your clock and their clocks are in perfect sync. The stars are far away and they are keeping their time, but you are keeping yours. There is a deep, profound comfort in being part of the same moment as the rest of your world. You don't need to move fast tonight. You only need to be here, in the quiet, in the dark, in the present. The tragedy of time dilation is fading. The light sail gamble is beginning. Let us move forward. Since we have accepted that the human body is too heavy and our lives are too short to survive the 40 trillion kilometer gap, we have had to change our strategy. We have had to stop thinking about giant metal ships and start thinking about something lighter than a feather. If we cannot move a mountain across the ocean, perhaps we can send a single grain of sand. This is the heart of the most ambitious and perhaps the most desperate scientific project in human history. It is called Breakthrough Starshot, and it is a multi-billion-dollar gamble that we can reach Alpha Centauri using nothing but light and a piece of glass no larger than a postage stamp. Imagine a ship that has no engines. It has no fuel tanks. It has no crew. It is essentially a single computer chip containing a camera, a power source, and a navigation system, all shrunk down to the size of a fingernail. This is the star chip, but a chip sitting in the dark doesn't move. To get it to move fast enough to beat the math of despair, we attach it to a light sail. This is a square of material so thin that it is measured in atoms, yet it spans several meters in width. It is a mirror designed to catch the wind of the stars, but the wind of space is weak and the distance is vast. So instead of waiting for the sun to push us, we decided to build our own hurricane. Plan involves a city of lasers, located in the high, dry deserts of Chile or the absolute silence of the Antarctic. Hundreds of massive laser arrays, all firing at once, focusing their energy into a single, blinding beam of light directed at the sky. This beam is more powerful than any light ever created on Earth. It is a concentrated spear of pure energy, and in the vacuum of space, that beam hits our tiny sail. On Earth, light feels weightless. It hits your skin and you feel nothing. But light actually has momentum. It has a tiny, microscopic push. When you hit an ultralight sail with 100 gigawatts of laser power, that tiny push becomes a violent, explosive shove. In just a few minutes of constant laser fire, this tiny postage stamp ship would accelerate to 20% of the speed of light. That is 60,000 kilometers every single second. At that speed, you could travel from the Earth to the Moon in about 6 seconds. You could reach Mars in less than an hour. It is a speed that is almost impossible to grasp. It is the fastest anything made by humans has ever moved. And for the first time in our history, the journey to Alpha Centauri starts to look manageable. At 20% of light speed, the trip takes 20 years. 20 years is still a long time, but it is a human time frame. It is the time it takes for a child to grow into an adult. It is a journey that we can start today and see the results of in our own lifetime. But as you settle deeper into the quiet of your room, let the reality of this gamble sink in. This is not a journey of exploration. It is a journey of survival. Because at 60,000 kilometers per second, the universe becomes a very dangerous place. Think about a single speck of dust. In your daily life, dust is nothing. It is a nuisance on a bookshelf. But when you are traveling at 20% of the speed of light, that speck of dust is a nuclear bomb. The kinetic energy of a collision at that speed is so intense that hitting even a microscopic grain of sand would vaporize the entire spacecraft instantly. There is no shielding thick enough to protect a ship that small. We are sending thousands of these tiny probes. hoping that at least a few of them find a path through the dark without hitting anything. It is a cosmic game of Russian roulette, played across 40 trillion kilometers of empty space. And even if they survive the trip, there is a second, more frustrating problem. These probes have no brakes. There is no laser in the Centauri system to slow them down. They will scream through the system at 60,000 kilometers per second, having only a few brief hours to take photographs and measure the atmosphere of Proxima b before they disappear into the dark forever. They are not settlers. They are photographers running past a window at 100 miles an hour, trying to snap a single clear picture of a world they will never touch. Then comes the silence. After the probe takes its pictures, it has to send that data back to Earth. It uses a tiny laser to beam the information across the void. But light, even at its maximum speed, still needs over 4 years to make that return trip. We would launch the probes, wait 20 years for them to arrive, and then sit in total silence for another 4 years, waiting to see if any of them survived. It is a 24-year wait for a few megabytes of data. It is a generation-long act of faith. This is the light sail gamble. We are betting that we can shrink our technology enough to make it weightless. We are betting that we can build lasers powerful enough to act as a cosmic slingshot. And we are betting that in the vast, empty void, our tiny messengers can find a way through the shrapnel of the stars. It is the only way we have right now to touch the neighbor. It is our only way to see if the red ghost of Proxima Centauri is really hiding a home. But as you drift further into relaxation, think about what this means for us. If we send these probes, we are admitting that we, the humans, cannot go. We are admitting that our bodies are too fragile for the void. We are sending our eyes because our feet cannot make the journey. We are becoming a species that explores by proxy, sitting in our warm, safe rooms while our tiny glass shadows do the work for us. It is a triumph of the mind, but a tragedy for the spirit. There is a strange, quiet dignity in this project. It shows that we haven't given up. We know the math of despair is against us. We know the speed limit of reality is absolute. We know that the void is a radioactive graveyard, and yet we are still trying. We are still throwing our postage stamp bottles into the infinite ocean, hoping that somewhere, sometime, someone receives the message. We are a species that refuses to stay in our room. But what if we aren't satisfied with just sending our eyes? What if the dream of actually standing under those amber suns is too strong to let go? If we cannot go fast, then we must go slow. We must change our definition of a ship. We must stop thinking about a vehicle and start thinking about a world. If the journey takes 1,000 years, then we must build a place where 1,000 years can pass. We must build a ship that can be a home, a school, a graveyard, and a sanctuary all at once. Imagine a vessel that is miles long, rotating slowly in the dark to create the feeling of gravity. Inside, there are forests, there are lakes, there are cities, there are people being born, living their lives and dying, all while the ship drifts toward a star they will never see. This is the realm of the generation ship, the most profound and difficult human experiment ever conceived. It is the ultimate sacrifice. Take a final, slow breath now. Let the image of the tiny, glowing light sails settle into your mind. Picture them as 1,000 points of light screaming through the void, carrying our curiosity into the heart of the triple sun. They are our scouts, our pioneers, our ghosts. They are moving at the limit of what we can imagine, fueled by a laser fire that is as bright as a star. But even they are just the beginning. The light sail gamble is fading. The generation ship is beginning. Let us move forward. If the light sails are our eyes and the probes are our scouts, then we have to face the final, most difficult question of all. How do we send our hearts? How do we send a living, breathing human being across a gap so wide that it swallows thousands of years? We have already seen that our current rockets are too slow, and the speed of light is a barrier that mass can never cross. This leaves us with a reality that is both haunting and beautiful. If we want to reach Alpha Centauri in person, we have to stop thinking of a ship as a vehicle. We have to start thinking of it as a world. We have to build a generation ship. Imagine a vessel that is miles long, a massive cylinder of metal and stone rotating slowly in the absolute dark. It doesn't move fast. It doesn't scream through the void like the light sails. Instead, it drifts. It is a slow, steady island in the interstellar ocean. Inside this ship, the rules of our lives are completely rewritten. On Earth, we live in a world of infinite resources. We breathe air that is purified by a global forest. We drink water that is part of a planet-wide cycle. But inside a generation ship, everything is a closed loop. Every breath you take, every drop of water you drink, and every scrap of food you eat has been recycled 1,000,000 times. This is the first great mystery of the long journey, the realization that you are part of a living machine that cannot afford even a single mistake. To help your mind hold the weight of this, think about the timeline. If the journey to Alpha Centauri takes 1,000 years, that is roughly 40 generations of human beings. The people who board the ship on Earth will be the only ones who have ever seen a real sky. They will be the only ones who remember the smell of rain on grass or the feeling of a natural wind. They are the founders. They leave behind everything they know for a dream they will never see realized. They will live their lives, grow old, and eventually be buried in the soil of the ship, their bodies becoming the nutrients for the next generation's food. They are the first sacrifice. But then we have to think about the people in the middle, the bridge generations. These are the people who are born on the ship, 500 years into the journey. They are in the absolute center of the void. They have never seen Earth, and they will never see Alpha Centauri. To them, the ship is the entire universe. The curved metal ceiling, painted with a fake blue sky and an artificial sun, is the only heaven they will ever know. They live in a world where nature is a small park in the center of a spinning drum. They are the ultimate prisoners of a mission they didn't choose. They exist only to maintain the machines, to keep the lights on, and to pass the torch to a future they will never touch. This is the most terrifying part of the generation ship. On Earth, we feel free because the horizon is open. But on a world ship, the horizon curves up to meet itself. There is no outside. There is only the mission. Every child born in the middle of that 1,000-year drift is born with a job already assigned to them. They are born into a destiny that was decided by people who died centuries before they were even conceived. It is a society built on a scale that ignores the individual. It is a masterpiece of human cooperation, but it is also a tragedy of human choice. As you settle deeper into the quiet of the night, let the silence of this ship settle over you. Imagine being a teenager on that ship, 700 years away from home. You go to school where you learn about forests and oceans from ancient videos. You look at pictures of the Earth and it looks like a fairy tale, a beautiful, impossible dream of a world that had no walls. You spend your days checking the oxygen scrubbers and monitoring the radiation shields. You know that you will live your entire life in this metal cocoon. You know that your children will do the same. You are a link in a chain that stretches across 40 trillion kilometers of empty space. You are a guardian of a flame that began on a planet you can never visit. But the mystery goes even deeper than the psychology of the crew. It goes into the biology of the journey. In a closed loop, nothing is ever lost. The water you drink tonight was the water your great-great-grandfather drank. The carbon in your cells was part of the plants that grew in the ship's garden 3 centuries ago. On a generation ship, the distinction between life and the environment begins to blur. You are the ship, and the ship is you. If the ecosystem fails, the mission fails. If a single species of bacteria in the soil goes extinct, the food chain collapses. It is a delicate, fragile balance that must be maintained for 1,000 years without a single catastrophic error. And then there is the arrival. Imagine the 40th generation. For 1,000 years, their ancestors have lived in the dark. For 1,000 years, they have maintained the dream. And finally, the amber suns of Alpha Centauri begin to grow larger in the viewports. The fake sky of the ship is finally turned off, and for the first time in a millennium, human eyes look out at a real star. But here is the ultimate twist: will they even want to leave? After 40 generations of living in a controlled, safe metal environment, will the surface of a real planet, with its unpredictable weather, its dangerous radiation, and its open horizons, be too terrifying to face? They would be a new kind of human, a species born of the void. To them, Earth is not home. The ship is home. The metal walls are safety. The open sky of a new world might feel like a void that is trying to swallow them. They might arrive at the neighbor's house only to realize they have become creatures of the doorstep. They might choose to stay in their ship, drifting forever around a star they never intended to land on. The generation ship is a journey that changes the traveler as much as it changes our understanding of distance. This is the math of the unborn. We are a species that dreams of the stars, but to reach them, we have to be willing to give up our humanity as we know it. We have to be willing to become part of a machine. We have to be willing to create a world where 1,000 years of human lives are just fuel for a single moment of arrival. It is a price that seems too high to pay, and yet we keep drawing the plans. We keep looking at the asteroid belts and the moon bases, and we wonder, could we build it? Could we be the founders of a story that ends 1,000 years from now? The generation ship is a reminder that the universe is not just big, it is patient. If we want to survive it, we have to become patient too. We have to stop thinking in terms of our own lifetimes and start thinking in terms of the species. We have to become a people that can plant a tree today, knowing that our great-great-grandchildren will be the ones to sit in its shade. Except in space, the tree is a star, and the shade is a new world. Take a final, slow breath now. Let the image of the miles-long ship, drifting in the absolute dark, settle into your mind. Picture the 40 generations of people, living and dying in the silent cradle of the void. They are moving through a darkness so absolute that the ship is the only light for trillions of kilometers. They are a single spark of life in an ocean of nothingness. They are us, and we are them. The generation ship is fading. The mystery of the great silence is beginning. Let us move forward. We have spent this entire journey talking about the distance. We have called it a wall, a fortress, and a prison. We have looked at why our fastest machines are effectively standing still, and why the human body is too fragile to ever cross the void in a single lifetime. But now we must face the most disturbing puzzle of all. If the universe is nearly 14 billion years old, and if our galaxy has hundreds of billions of stars, then even a gap of 40 trillion kilometers should not be enough to stop a determined civilization. In the grand timeline of the cosmos, 4 light-years is nothing. It is a tiny, insignificant gap. So, as we point our most sensitive ears toward Alpha Centauri, we have to ask the question that has haunted every astronomer since the dawn of the radio age. Why is it so quiet? For over a century, humanity has been a noisy species. Since the invention of radio and television, we have been unintentionally leaking our existence into the cosmos. Every radio broadcast, every television show, and every radar pulse from our military installations has been screaming out into the void, traveling at the speed of light in every direction. We are surrounded by a radio bubble that is now over 100 light-years wide. This means that Alpha Centauri has been inside our bubble for a long time. They have had decades to hear our music, our news, and our voices. If there is a civilization there with technology even slightly more advanced than ours, they know we are here. They have known about us for a generation. And yet, when we listen back, we hear nothing. We have pointed our massive satellite dishes toward those 3 suns for thousands of hours. We have scanned every frequency, from the low hum of radio to the high-energy bursts of lasers. We have listened for a hello, a signal, or even just the accidental noise of their own technology. But the result is always the same: absolute, unrelenting silence. This is the heart of the Fermi paradox applied to our own backyard. If the conditions for life are so common, and if the nearest star has a rocky planet in its habitable zone, why is the sky so empty? To understand the weight of this silence, think about the water hole. This is a specific frequency in the radio spectrum, around 1420 megahertz. It is the frequency at which hydrogen, the most common element in the universe, naturally vibrates. Astronomers call it the water hole because it is a quiet, universal channel where any intelligent species would logically choose to broadcast if they wanted to be found. It is the cosmic equivalent of a town square. We have sat at this water hole for decades, waiting for a single drop of information, but the well is dry. There is no one there. This brings us to the first major possibility, one that is both sad and profound: the Great Filter. Scientists wonder if there is a barrier in the evolution of life that almost no one survives. Perhaps it is easy for a planet to grow bacteria, but almost impossible for it to grow a brain. Or perhaps once a species becomes smart enough to build a radio, it also becomes smart enough to build a bomb. Maybe every civilization that reaches the point where they can talk to the stars eventually destroys itself before the first message is ever sent. If this is true, then Alpha Centauri might be a graveyard. Proxima b might be covered in the ruins of a people who reached for the stars and fell back into the dust. We might be listening to the silence of a tomb. But there is a second possibility, one that is far more terrifying. It is called the dark forest theory. Imagine the universe is a dark forest at night, filled with silent hunters. In this forest, survival depends on being the one who is not seen. If you are a hunter and you hear a twig snap in the distance, you don't shout hello. You don't turn on a flashlight. You stay quiet, you pull your cloak tighter, and you prepare to defend yourself. You assume that whatever made that noise is a threat. If the galaxy is a dark forest, then humanity is the only one in the woods who is screaming at the top of our lungs. We are broadcasting our location to everyone, unaware that the rest of the universe might be hiding in the shadows, terrified of being found. According to this theory, the reason Alpha Centauri is silent isn't because there is no one there. It's because they are smart enough to stay quiet. They are watching our radio bubble expand toward them, and they are choosing to remain in the dark. They are the silent neighbors who are watching us through the curtains, refusing to answer the door. Think about what this means for our search. We are desperate for a signal. We want to know that we are part of a larger community. We want to believe that there are other minds under other suns, but we never stop to ask if we should be careful what we wish for. If we did hear a signal from Alpha Centauri tomorrow, it would be the most important event in human history. But it would also be the end of our innocence. We would no longer be the masters of our own story. We would be part of a hierarchy that we don't understand, facing a power that is 4 years away and millions of years ahead of us. As you settle deeper into the quiet of the night, let this silence settle over you as well. There is a strange, hypnotic peace in the idea that we might be alone. It makes our Earth feel more important. It makes our own voices feel more precious. If Alpha Centauri is empty, then the light of human consciousness is the only light in this corner of the galaxy. We are the ones who give the universe a name. We are the ones who give the stars a meaning. The silence isn't a lack of something. It is a space for us to exist. But what if they are there, but we are simply too primitive to understand them? Imagine a colony of ants living next to a high-speed fiber optic cable. The cable is carrying millions of messages every second. Books, movies, secrets, and songs. But to the ants, it is just a strange, cold tube in the dirt. They have no way to tap into the signal. They have no concept of what information even is on that scale. We might be the ants of the Centauri system. We are looking for radio waves, while the adults of the universe are communicating using methods we haven't even dreamed of yet. They might be shouting right past us, and we are just too small to hear it. This is the great silence. It is a mystery that isn't about distance, but about time and survival. It reminds us that we have only been a technological species for a tiny fraction of a second in the cosmic clock. We are the newcomers. We are the ones who just walked into the room. It is natural that we are the only ones talking. We are the children of the cosmos, still excited by our own voices, while the elders of the galaxy have moved on to a deeper, more profound quiet. Most people find this silence frightening. They find it lonely. But if you look at it differently, the silence is a gift. It gives us time. It gives us the chance to grow up, to solve our own problems, and to learn how to be a species that can survive for 1,000 years before we meet someone else. The moat of 40 trillion kilometers isn't just a physical barrier, it's a biological one. It ensures that we are ready before we ever have to face the neighbor. As you get sleepier and the silence of the room surrounds you, try to visualize that radio bubble. See it expanding outward from Earth, a sphere of invisible noise, music from the 50s, news from the 90s, the digital hum of today, all of it moving at 300,000 kilometers per second. It has already passed Alpha Centauri. It is moving further out every second. Somewhere in the deep dark, that noise is reaching the ears of stars we haven't even named yet. We are calling out into the night like a child calling for their parents, and for now the night is not answering, but that doesn't mean no one is there. It just means that for tonight, the universe is content to let us be. It is content to let us dream our own dreams and tell our own stories. The silence is not a rejection, it is a sanctuary. Take a final, slow breath now. Let the mystery of the great silence fade into the background. You don't need an answer from the stars tonight. You only need the peace of the quiet. The stars are there and they are silent, and in that silence you are safe. The great silence is fading. The protective moat is beginning. Let us move forward. We have spent this entire journey standing at the base of a wall. We have called it a fortress, a prison, and an impassable ocean. We have looked at the 40 trillion kilometers that separate us from Alpha Centauri and felt the crushing weight of our own insignificance. We have seen that our fastest machines are like snails in a desert, and that the very laws of physics seem to have been written to keep us apart from the stars. It is easy to look at this distance and feel a sense of despair. It is easy to feel as though we are trapped on a tiny, fragile island, surrounded by a moat so vast that we are effectively alone in the dark. But as we reach the end of our exploration, we have to look at the wall one more time, because in the cosmic dark, a wall is not just something that keeps you in, it is also something that keeps the rest of the world out. Tonight, we look at the final mystery of the void, the realization that the distance is a gift. We call it the protective moat. Imagine for a moment that the universe was not this large. Imagine if the stars were as close as the planets. If Alpha Centauri was only as far away as Mars, our sky would be a place of absolute chaos. The gravity of those three massive suns would reach out and tug at the Earth's orbit, pulling us out of our stable circle and into a path of fire and ice. The radiation from Proxima's flares would hit our atmosphere with the force of 1,000 suns, stripping away the air we breathe and boiling the oceans. Life requires stability. It requires a quiet, protected corner where it can spend billions of years evolving in peace. The only reason we are here tonight, the only reason you are able to breathe, to think, and to dream, is because the universe has provided us with a 40 trillion kilometer buffer of absolute silence. Think about the violence of the cosmos. Out there in the deep reaches of the galaxy, stars are exploding. Black holes are tearing apart entire solar systems. Supernovae are screaming outbursts of gamma radiation that can erase life from thousands of light years away. If the universe were crowded, life would be impossible. We would be caught in a constant crossfire of cosmic destruction, but the moat of the interstellar void acts as a shield. It is a vacuum so perfect that it absorbs the violence. It is a space so vast that it thins out the danger until it is nothing more than a faint, beautiful light in the sky. We are lonely because the universe is protecting us. We are isolated because we are precious. Most people look at the stars and see a destination they want to reach, but perhaps we should look at the stars and see a reminder of why we must stay. We live on a world that is a statistical miracle. We have a sun that is stable. We have an atmosphere that is just right. We have a moon that keeps our tides moving and a magnetic field that wards off the shadows. On Earth, the rhythm of life is gentle. We have mornings that turn into afternoons and seasons that turn into years. We take this for granted because it is all we have ever known. But as we have seen in our journey to Alpha Centauri, this peace is not the rule. It is the exception. As you settle into the final, deepest part of your rest, let the realization of your sanctuary wash over you. The silence of your room is not a lonely thing. It is a reflection of the silence that keeps our world safe. The darkness outside your window is not a void. It is the moat that ensures your tomorrow. We spend so much of our lives worrying about the small things, the deadlines, the traffic, the petty disagreements of the day. But from the perspective of the 40 trillion kilometers, these worries vanish. They are smaller than a pixel. They are ghosts in a world of giants. If we ever do cross the void, if we ever send our light sails or our generation ships to the heart of the triple sun, it will not be because we hate our home. It will be because our curiosity is the only thing as large as the distance itself. We are a part of the universe that has developed eyes to see and a mind to wonder. We are the way the cosmos looks at itself and asks, "How far can I go?" But even as we reach for the stars, we must remember that we carry our home with us. Every atom in your body was forged in the heart of a star that died long ago, and every breath you take is a connection to a biological chain that has survived for billions of years. You are a traveling piece of the earth, venturing out into a darkness that is older than time. There is a deep, soul-stirring peace in knowing that the wall is undefeated. It means that there are still mysteries left to solve. It means that there is still a reason to look up. If the universe were small enough to fit in our pockets, it would no longer be a place of wonder. It would just be another room. But the interstellar void ensures that the stars remain stars. It ensures that the neighbor remains a dream. It gives us a horizon that is always moving, always calling, and always reminding us that there is something grander than our daily lives. Take a slow, deep breath now. Visualize our ship, our silent needle of light, drifting back from the Centauri system. We are leaving the amber suns and the red ghost behind. We are turning back toward a tiny, pale blue dot that is hanging in the dark, billions of miles away. It looks so small. It looks so fragile. It is a single spark in a dark cathedral, but as we get closer, we feel the warmth. We see the familiar continents. We see the clouds and the oceans. This is the only place in 40 trillion kilometers where the air is soft and the water is sweet. This is the only place where a heart can beat without a machine to help it. We have explored the math of despair, the waltz of the suns and the silence of the void. We have seen the forbidden home and the lightsail gamble. We have traveled through the past and into the potential future. And after all of that, we arrive back at the same truth we started with. The distance to Alpha Centauri is terrifying. It is vast. It is impossible. And it is exactly what we need. It is the silence that allows us to hear our own voices. It is the darkness that allows us to see our own light. The journey is over, but the wonder remains. You are safe, you are home. The moat is wide, the wall is high, and the stars are watching over you with a patient, ancient light. They have been there for billions of years, and they will be there for billions more. They do not demand anything from you. They do not ask you to hurry. They only ask you to look. Let the numbers fade away now. Let the trillions of kilometers become nothing more than a feeling of total, absolute peace. The scale of the universe is not a weight to carry. It is a blanket to rest under. You are a small part of a magnificent story, and for tonight, your part is simply to sleep. The The stars will continue their dance without you. The void will remain silent, and the earth will continue its gentle tilt through the dark. Close your eyes now. The light of Alpha Centauri is 4 years away, but the peace of your own home is right here. Let the silence be your comfort. Let the darkness be your sanctuary. The journey is complete. The stars are at rest. And so are you. Good night.